Hello, so today I'm going to be taking you through the geologic geometry resource that I made using SolidWorks. So this one in particular is in relation to road geometry, and I'm just going to take you through kind of the main parts of it, how it's going to be helpful for pupils, and kind of why I've created it. So what the main point of this is just kind of to help pupils visualize like how the lines that they are drawing when they're creating these questions. So this is a simple enough road. It's a flat formation level. There's no rise in it, so this is kind of to be used for pupils who are beginning the topic, just kind of to show them how their lines are affecting the question and what they're actually doing when they're creating lines and these types of things. So the first thing we can do with this question is, you can see we have our cut slopes in here and our embankments in here, is just to get people to suggest what the ratio for the cut slopes and the embankments are. So this is just to get everybody into the way of thinking about these questions and type of thing. So we'll start off with the embankments. If we get pupils to suggest what the ratio for the height of the embankment compared to the width of the embankment is. So you can see it's 1 to 1, but this is just to get people thinking about it. And then the same thing up here, do the same thing with our cut slopes up here. So just get them to suggest the general ratio. So here you can see we have 1 is to 2 or 2 is to 1. And so what we can do then after we've created that, or after we've done that, is to show pupils how they're drawing their lines. So this might be something you do maybe after pupils have created a question already. So what we'll do is I'll just get the section view going here. Okay, so you can see we have a section view to the top plane here. I'm just going to take it right the way down until it's at our formation level, or very nearly. Right. Okay. So you can see pupils know that I'm going to start off with the embankment because it's at a ratio of 1 to 1, and pupils know that when they are stepping out their lines, it's going to be, for example, if there's a distance of 10 between the contour lines and there's a ratio of 1 to 1, then we multiply our ratio by the difference in between our contour lines. So pupils are going to know that we're not going to need to step out 10 mil, but they're not. I'd say most pupils would be unsure of why this is. So if I could demonstrate here using our sectional view, if I go down, we'll call that 10 meters there. And pupils will have been able to see now that I have travelled down a distance of 10 meters, like so, using our cut slope. And also, if I travel down, because it's a ratio of 1 to 1, if I travel down 10 meters, you can see that our cutting plane also travels out at a distance of 10 meters. So because of this is the main reason why, this is the reason why we travel out a distance of 10 meters. Because as you can see here now, if I go back up into a top view of it, you can see that I have found 2 points here, one here and one here, that are out a distance of 10 meters, and that would be hitting a contour line that would correspond to the same distance. But this is just generally showing people how this works, and visualizing it is the main point here. So then I could show pupils again, I can continue on this process and say, okay, I can get a suggestion from the class. So we could try and find out if everybody believes this. There's bound to be a few non-believers and think, well, how does this work? So if I get them pupils to suggest a distance down for me to travel, so we'll just go another random distance, say that was a distance of 30. So you can see here, if I was to measure the distance between this line up here and the distance we've travelled out, I know that that is going to be equal. So that is why if we travel down 30, then that would correspond to 30 out the way as well, 30 meters. So I could go back up into my top view, or my plan view, whichever one you want to call it. And now we can see that because we've travelled down, we've found another point here, which would be connecting with a contour line, or is connecting with a distance or a point of just general earth. And then I've got another one over here that would be connecting with that there. So that would be how to show people how to do one with a ratio of 1 is to 1. But you can see that our embankments were a different ratio, so they were 2 is to 1. So how would we go about showing people that? So we'll start off here. We'll get back at the formation level. And what we're going to do is, we're going to get the same thing again. So, right, everybody's seen that the last question, or in the last example, there was a distance of 1 is to 1. And if we travel down 10 meters, that means we would have been going out a distance of 10 meters as well. So if this is a ratio of 2 is to 1, what would the distance travelled out be if we travelled up 10 meters? And we'll get pupils to suggest that, and hopefully their suggestions would be appropriate. So you can see here now the difference that we get. So you see I travel up, so this is hypothetical obviously, but I travel up a distance of 10 meters, and you can see here that the distance I've travelled out is different to the distance I travelled up. So this would correspond to 20 meters. So pupils would hopefully have been able to suggest that for me. And then this is a good tool to help pupils visualize it again, as I was saying, what they're doing when they're creating these lines. And you can see here that, so the distance out is 20 meters like that there. So there's a different ratio. And then we'll go back into our top view. I'm just going to zoom out a bit here. Go back into our top view, and you can see here now that we have generated 2 more points. And you can see that they're further out than they would have been on the last example, because we would be creating our lines at a distance of 20 out this way, whereas the last time they would have been going in steps of 10. And you can see here that we've found a point here on our cut surface and a point here. So we can do the same thing again. We'll just demonstrate for a few more ones. I just want to get this a bit more centered. We could do this again for a few more examples. So if we get the same thing again, get a few people's suggestions, what distance do they think roughly we should travel, and I'll go another. So if we were to travel up another 10, and now we can see that we've travelled out a further distance. So you can see the distance again has jumped by another 20, and you can see we have a point generated here and a point generated here. And we can go back again, and we can keep repeating these steps. So go up another jump of 10 meters, and you can see here that we're way out now compared to what we were in the last example. And this would be because if we're doing this correctly, so this would be if we've done 3 jumps of 10 meters up, so then that would correspond to 3 jumps of 20 meters out. So you can see here that we've found another point here and a point here, and you can keep going all the way up until we find the very top. So now you can see here that on our cut slope, that because we're only taking jumps of what relates to the contour line, we could actually take a point anywhere along these surfaces here, and they would be correct. But because in our examples we only have contour lines to work from, this is why we need to relate our ratios to our contour lines in the same way. Because if we had a contour line for every area on the map, then we'd be able to kind of be a lot finer with our sketches as well, and of where the area where the embankment or the cut surface hits off the lay of the land. Then we could be a lot more accurate with that there. But then we could also use this example to show pupils. So because we only have contour lines of distance of 10, then that's why we have to be, taking these jumps in a distance of 10, and maybe kind of being a wee bit, letting kind of things flow a wee bit with our, with our sketches in of where the lie of the land lays. So that's my resource there. I've gone through kind of why I've used it. So it's just really to help people visualize what they're doing when they're creating these jumps or creating these lines out of. So in the embankment it would be an example of 10 meters, or in this one here it would be an example of 20 meters, and that's why I've done it. And hopefully I feel it'd be a worthwhile resource for people to look at anyway. So thank you.